Good evening, friends. Welcome for the session. So today we are going to understand one of the classification model. So let me recall what we have discussed so far. So the day one, we try to understand what is the application of machine learning and artificial intelligence with respect to domain analytics. And we understood what is the steps that we follow, that is project management methodology that we follow for machine learning. So crisp MLQ, and later we took data pre-processing and data cleaning as a portion to understand how we need to understand or analyze the data, that is exploratory data analysis. And then we understood one of the clustering model, that is machine learning unsupervised learning model. Then we understood one of the linear regression model, and again classification model, KNN. So today we'll also try to understand one of the classification model, that is decision tree. And tomorrow we'll just discuss how artificial intelligence or deep learning or artificial neural network, what we call, is helping the hospitality analytics, where we have a huge data that is going to be having that is going to be giving more insights and predictions methods from the particular data. So we'll start understanding what is first decision tree classification model, and then we try to understand. So the name itself says that it is a decision tree, and it is a tree-like structure, where importantly we have three types of nodes, that is a root node and a branch node and the leaf node. So all the threes are important nodes that is helping us to make several decisions. Let's say example, you have one condition, then you'll be having a decision bit easy for make your decisions when you have one condition. When you have multiple conditions, it is too difficult to make your strategies and making and taking your decisions. So that's the reason we have a tree-like structure. When you make a tree-like structure, it is always easy to understand and get the decisions done without losing any of the data. So hence we use decision tree structure to make your own decisions and predictions in machine learning algorithm. So when we build the model, we have a tree-like determines, where we have a variables or the features or the observations that we see will be split at a node, and will split the value what we are going to assign to that particular node. So when we have a variable, or the features, will assign that as a branch node or root node. So based on what criteria you will be selecting the variables or the features of the particular data set. So we do have something by name entropy. So when we have a variation, more changes with respect to different scenarios or criteria, we call it as entropy. So we determine the value when there is a lot of variations or the changes. So based on that particular entropy, we'll get the information gain. So once we get the information gain of that particular variables or features, we'll calculate what is the main importance or the value of that particular feature in the whole data set. Which mentions it which mentions or it gives you the value that needs to be in the root node or branch node. Because whenever we have a data, these are the features. When we have a features, we just need to decide when you have an output. So since decision tree is under supervised learning model, where we categorized as classification model, we already know the data will be in a categories. So categories or classes, binary classification or multi-classification. Once you reach at the leaf node. So once we reach the leaf node, so leaf node will be your output column. So in the particular data set, you have combiningly with input as well as output. Okay. So the column which is dependent on the other features will be validated using these values: entropy, information gain, and gain value. Specifies which one should be considered first, or specifies which needs to be given more preference. If there are multiple variables, we just need to go and check which variable is providing me more profit. Helping to understand which is predominantly used, which feature needs to be concentrated. So it is help us to take our strategies, make our strategies different, and take our decisions immediately. So hence the decision tree is helping to make our predictions. So now we'll see how we take the values. So I'll just show you one table. So this is your table. So this represents where you just need to have a Bayes computer. So where you'll be having age factor, income factor, student factor, and credit rating. So when you are buying a computer, either you are buying or not buying, depending on all these features, not only one criteria, it depends on all the features, but which one is more important, which one is given priority. So whether the age factor is given priority, first option, or income second, or student third, or credit rating next. So it will give you all such information, that is the features or the variables that are to be considered to enhance or decide or predict what will be your next factor or what will be your output. So my output or the objective is to buy a computer. If the age factor is 31 to 40, and the income is high, and the student is not a student, and the credit rating is fair enough, he'll buy the computer. So any one of these criteria satisfied, it will be a buying a computer. Okay, so there can be many possibilities. Even you can see that 31 to 40, low, and S and excellent, you will be having S criteria. Just a minute, friends. Sorry, friends. So now we just need to understand whether age is impacting on the result or income is dominating to get the computer, buy the computer or not. And the student, whether he is a student or is not a student, is impacting the computer, or credit rating is impacting the computer, buying a computer. This is one simple example for us to understand decision tree. This is not the ultimate one. Okay. So the information gain or the information will be calculated with the help of the formula this. So this will be used in the model where it will be giving you the entropy. So we have entropy, which is minus sigma 1 to m pi log of 2 probability, that is pi. So pi is probability. So this is the information of the whole data set. So how do you calculate probability? Let's say example, I'll go to here. Now, when I consider buying a computer, what is the total number of rows that you have? 14. Okay. Out of which you have two things. One is yes and one is no. So what is the chance of getting yes out of 14 times? What is the chance of getting no out of 14 times? So what do you write? So chance means probability. So the probability of getting the values, the probability of getting yes out of 14 times, we call it as the probability. So how do you calculate that? Out of 14, we have S 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 times you have S, then the probability of getting the S is 9 by 14. So remaining, obviously, it will be no. So probability of getting no out of 14 times is 5. So it is 9 by 14 and 5 by 14. So this is how you calculate the probability, Pi. So using the information gain of whole data set, you will calculate the minus sigma I1 to m, that is all the particular features. So Pi log of Pi. So you calculate the probability, 9 by 14, and here also 9 by 14. So you calculate for both yes and no. So that is what I1 to m. So you have two categories. So hence you find the information gain. So information gain of particular data set, the output, this is for output, will give you minus Pi. Pi is for yes. I'll just write here yes, log of PS. Okay. So minus P no, probability of saying no. Okay. So P no. Now, yes means 9 by 14 minus log of minus 9 by 14. This is plus minus 5 by 14 log of 5 by 14. So when you calculate this, you'll be getting information gain of whole data set. This is for whole data set. Why we are considering the dependent variable, but not estimating each individual. You want to estimate each individual, then we need to consider one by one. So how do you do that? So let us consider age factor. In this, how many categories you have? You have three categories. One is less than equal to 30 and 31 to 40 and greater than 40. So in this three categories under age factor, how many are saying yes and how many are no? So that is what we need to calculate. So for that, what you'll do is for the age factor. So for the age factor, we have three criteria: 31 to 40, less than or equal to 30, greater than 40. Okay, three times. So you have two options. One is yes and one is no. Okay. So now here, when I consider 31 to 40, I need to calculate what is the yes and no. So how many 31 to 40 you have? 1, 2, 3, 4. 3, 4. So 1, 2, 3, 4. So there are 4. But out of which, in these 4, how many are saying yes and how many are saying no? We just calculate. So you can see that this is yes, and this is yes, and this is yes, and this is also yes. So you have yes 4 out of 4. Everything is 4. So you don't have an opportunity to calculate what is no. So you'll have out of 4, all the 4 are 31 to 40. That is the meaning. Okay. So now going on to the next. Moving on to the next. So we have what we have less than or equal to 30. So 1, 2, 3, 4, 5. Okay. So you have 5. So this you have 4. Okay. Now out of 31, out of less than or equal to 30, out of 14, how many are yes, how many are 5? No. So you have 5, out of which some should be yes and some of them should be no. So we'll see that. So 1 is no, 2 is no, 3 is no. So we can identify 3 no and 2 yes directly. So the probability when yes is given. So when the probability of yes is given, you need to identify what is the probability of getting less than 30. So using this equation, we'll calculate. You can see that out of 5 times existing, out of you are getting 5 times. You have 5 times. Okay, out of 5 times, you have 3 times yes and 2 times no. So we just need to understand here the probability that we are using is Navy Bayes probability. Okay, so this is the probability that we are going to use. Here it is 4, here it is 5. Now, next option is greater than 30. So when you have greater than 30, how many are there? 3, 4, 5. So can you please count this and then tell me what is the amount? It will be 14. So you can see that you have 14 observations. So you need to get 14. So greater than 40. How many greater than 40 are there? 5 are there. How many are yes and how many are no? So you have 1 yes, 2 yes, and 3 yes. So 3 yes. So again it is 3 by 5 and it is 2 by 5. Now after getting this value, okay, let me after getting this value, you just need to understand what is the probability of finding with respect to that. So you just need to do individual information gain. So information gain of 31 to 40. So you don't have an opportunity because it is 4 by 4. Log 1 is 0. So no information gain in this. So information gain of less than equal to 30 you have 3 by 5. This is minus log of 3 by 5 minus 2 by 5 log of 2 by 5. So once you calculate, you'll be getting what is the information gain of this. Now, next, again, minus 3 by 5 log of 3 by 5 minus 2 by 5 log of 2 by 5. So this is my information gain of that particular parameter. Now for the same, you just need to calculate greater than 40. So once you got that particular value, you just need to calculate what is the information gain of whole age. I want that particular information gain of whole age. So what you will do, you just need to have 4 things, that is 31 to 40 less than equal to 30 greater than 40. So you have 4, 5, 5. So out of 14, all these are having the values. So each individual, you have information gain of 31 to 40. You have information gain of less than or equal to 30. You have information gain of greater than 40. So with these 3, you just substitute here and get the value. That is a formula that we get for a particular feature, information gain of the particular feature. So once you get that particular feature value, you just need to subtract from the main information gain. What is the main information gain that we got? Buying yes and no. So with this, we get the formula, and subtracting that, we get 0.246, some value. So this is my gain of that particular column. Like the same, you have income column, you have student column, you have credit rating column. So all these will be calculated and will be cross-verified, which is having more gain, So age, okay. So when we calculate the end, you'll be getting a gain value for age, income, and student, and credit rating. So among these gain, you just need to select the highest one. And next highest one. Like this, you just need to consider the highest one and make the tree. So first highest gain value is age. So under this, you have 3 categories, that is 31 to 40, less than or equal to 30, greater than or equal to 40. After age, you have student, next gain value. So this should be taken in descending order because you are going from top to bottom. This is how you should take. Okay. Next, income. Next, you take credit rating. Okay. So instead of income, even if you don't take income, we can just analyze the output. Okay. With the help of student, age, and credit rating, you can easily understand the data. So when you don't have income, or when you have income, doesn't matter. So the decision can be taken based on first factor as age. This is the important factor that you need to keep in mind. And next, whether he is a student or not, and then credit rating. So all these 3 impact a lot. So first factor is age. So with the help of decision tree, we come to a conclusion which feature needs to be given important based on the output, which is dependent on age, student, and credit rating. Okay. So now we'll see the same in our domain analytics, that is hospitality analytics. and then try to understand how similar we are understanding. So when we understand something, we just need to do it with respect to project management or any machine learning model. So first we need to follow the project management methodology. Okay. So first what you'll do, you understand the business, and then you understand the data, then you perform EDA, then you model selection, and model evaluation, and then model deployment, and then maintenance. Okay. So this is how you need to proceed further. So now we understood the business, saying that we need to predict the strategy, or we need to make the decision. Okay. So in predicting the demand of that particular bookings. So that is my business. So we understand the data, or we do data pre-processing, and then analyze the data. With the help of EDA, we check whether it is having outliers, whether you need to do some typecasting, whether you need to fill the null values. So like that, graphically or calculation, by doing calculation, we can just go ahead with EDA. And we select the model selection, and we go over model evaluation by testing, and then we maintain. So we'll just directly go into the data. So we'll take the data, and then we'll try to understand graphically, and then we'll go ahead. So I've taken the hospitality data, hotel booking data, and this is my head data, that is top 5 rows. And then after that, I describe the data, which gives me a mean value, count value. This is not necessary, but it's our understanding. Okay, so it will work only on the numerical columns. Now, moving towards information, that will give you how many null values are there, how many not null values are there. So here you can see that the country column having null values. So that means this gives you 6,000 out of 11,009, 1,19,386 or 390, out of which 6,797 is not null. So that means it remaining all other are, so 5 lakh almost, so 5 lakh or 5.5 lakhs almost, their null values. So it gives you information that which is having null values and which is not having null values. Okay. And next, moving further, we just need to understand the data with null values. How many are there, and what is the percentage of that particular column contributing for null values. So in the country column, you have a null values, and that is only the contribution given by the particular column. You can see that 94% it is empty. So 13% it is empty. So like this, we can just analyze what is the percentage of the null values. So now we just need to understand what is the data that we need to fill if it is empty, and then we visualize that with respect to the plot, and it gives you the count, how many children are there, how many adults are there, how many babies are there, and we filter that and we exclude that particular portion, because sometimes the zero, the count will give you go down with the accuracy level. So while calculating, we just need to analyze whether it is encoded part or not. So hence it will be affecting the accuracy. So we just need to change that as per our requirement. So we just remove that particular columns and then we analyze the data. Now, once we analyze the data after getting it, we start doing exploratory data analysis. So country wise, we take country wise, which is cancelled in that particular, which is the country, and get the count value. Okay, so for that, we just need to understand and explore to understand from which country the more bookings are there. And this is a graphical representation which gives you more information that which part of the country is having booked with a particular resort or hotel, and then decide to decide and make your more strategies. So you'll understand the data with the graphical representation. So for that, we use folium.map, and we just chorop let. So we just need to use this to get the world map and then design that. So that is a head portion. And we also easily understand if it is 0. So cancelled in that particular column, if you have 0, then for which particular room type, it has been cancelled. And also we just need to understand what is the average daily rate and the template. And this is a representation, graphical representation, how particular data has been designed, and the bookings and the cancellations as done. So you can see more outliers in most of the city hotels. So we just need to understand that and need to decide our things. So data resort, the resort hotel and cancelled, we just need to bifurcate it to two different things, because the resort bookings are different when compared to the bookings of city hotel. So we just need to understand the bookings with respect to resort hotel, and it is grouped by with the arrival date month, with a month wise, and here also city with group by arrival date month. And then we understand the final hotel where you have a resort hotel and you also have with the city hotel. Okay, so we just need to merge with those two data frames with respect to month, price of the resort and the city. So you can see that. So month, price of the resort and price of the city hotel. So after that, we need to get the data frame sorted with respect to month or week or days. So for that, what we'll do is we use the sort month, where the data frame will be sorted with the help of month and the particular column name that we pass. So here, what we do is sort month. We gave the final hotel. What is the final hotel that we have here? Month, price of resort and city. So using that particular data, we get the particular month which is having a sorted, You can see that it has been sorted here. And after that, we get the final price that is predicted for the resort based on the booking. Okay, so you can see that price for resort has been increased in the month of August, and it has been decreased in the month of November. And after that, we can just also understand the arrival date of the guests in the resort with the help of this command, where you say that arrival month, date, and number of guests, like how we have done for the city resort and hotel resort. The same concept, we understand the guests that are there in the resort using the month and number of guests. So you can see that when you filter that, you'll be getting August month, you have more number of guests. And the city guest, you have number of guests and arrival date month. So final guest, also you can just make combining merging of two things, that is number of guests in resort, number of guests in city. So with that, we get the final guest that is sorted again. So you can see that it has been sorted January, February, March, April, May, June till December. And after that, you get the final guest with respect to the number of guests that you have in the resort. And you can just analyze the is cancelled. So earlier we used to drop that particular filter, and now we need to add that, and we need to get that how many of them have cancelled based on the particular month. We just need to cross verify. So here you can see total stayed with respect to nights and total with respect to days. So here you can see group by with the total nights and hotel. So this is all with respect to exploratory data analysis. So you can do it as per your convenient, as per your problem statement. So this is a correlation that we have cross-verified between the variables. So after performing correlation, you will be getting a values between 0 to 1. So we'll drop some of the columns that we don't require. And after that, we'll use only the particular columns which do required. Okay, so these are the categorical based data that we do require. So reservation status of date with respect to month, day, and year, we'll just segregate that. And we consider the columns that are unique with respect to the hotel, the market segment, the distribution channel, because all these are categorical based data columns. So you can see here, hotel, you have resort hotel, city hotel, and for meal, buffet, for market segment, you have different. So like this, you will be getting the criteria. You will be getting categories under the particular column. You can see this. So all these criteria you will be getting from this CAT-DF columns. We'll just categorize that, and then we'll make use of that. How many are there? So you can see that we have categorized and we number that 0, 1, 1, 2, 3, 4. This is all with respect to encoding part. So one-out encoding and label encoding, we can also do like this, and you can also do with respect to dummy. And we drop the is cancelled. And after that, we'll calculate what is the data frame that we have underscore data frame with the variance. And we have lead time, arrival date time, arrival date, day, month. So all these will be calculated, and the variance will be calculated to identify the variation in the data by taking the logarithmic transformation. Here you can say that you have taken the log value. Okay, so that will give you what is the transformation that will help us to calculate with the by taking less time. So moving forward, we'll just have a look into ADR. If you have any null value, you just need to fill that particular value with a mean value that we have created using the mean. and we'll concatenate the cancelled one with respect to num underscore df and categorical data. And then we'll get the data set divided as trained data set and the test data set. And once we divided that, we'll pass the data set into the model. That is, our model is decision tree model. So we take that particular model. Here you can see that we are taking decision tree classifier and we're passing that and fitting the model using trained data set. So we'll predict the particular value with the test. So here we are creating DTC. So that is going to fit with respect to trained data. So what we have, the for 60% or 70% data that we have split will be considered for the training the data. And we just need to calculate what is the accuracy that we are getting for test data. And once we get the accuracy level, we just try to understand what is the F1 score. So you can see that you are getting F1 score as 96%. So this gives you that your data is 90%, 96% accurate. And whatever the analysis that you have done for the given data, that is your absolute data. So that is your accuracy. So here the entropy, the information gain, and the gain will be calculated with the help of this particular model that what we have used here. Decision tree, you can see here, decision tree classifier. So this will be done and it will be ready. So once you pass the value, it will calculate. So you can see that. So here we have our data. So all these are categorical data. Okay, so we need a probability for that. So hence we have converted to numbers. So earlier, I'll just show you here. You can see that we need a probability of that. So we also already have all the values in numerical data, but we do have some of the values that is in the categorical data. So after that, we use that and then we'll convert that to a categorical data. And then we'll try to use it for decision tree classifier. So here you can see that we have calculated. So categorical data frame of hotel, meal, market segment, distribution channel, reserved room type, deposit type, customer type, year. So among all this, which is having gain, which is having more gain, will be calculated by model, and that model will gives you that you whatever you have predicted is correct. Whatever you are saying is correct. So that means whenever there is a cancellation, E is cancelled. So this is how the decision tree takes place. You can see here. So if you have any questions, you can just let me know. So there is one question that the confusion matrix that has been used here. So you can see that the confusion matrix, what they have used is to get the scenario with respect to actual and prediction. Okay, so when you have true, false, true positive and false positive, true negative and false negative, and the combination of these precision, accuracy, recall, so all will be together constituting your F1 score. Okay. So from the data set, it will directly predict some values. So it will calculate what is the actual data. So it will compare with that actual and prediction. So once you don't have any much difference, let's say example, when you do a prediction and actual calculations, your error should be less. So prediction minus actual, this error rate should be less. So only then you will be getting 0.96, that is 96% accuracy. That means 4% error. So with the help of confusion matrix, we can make use of accuracy level of the model. So whenever you use classification model, you can directly make use of this confusion matrix that will leads to get the accuracy level, so that you can check for the accuracy of the model. So if you have any queries, you can just discuss. Otherwise, good to wind up. Okay, friends, we'll wind up here and we'll meet tomorrow to understand artificial neural network, how it is going to help us, and what is the accuracy level that you are getting apart from machine learning. Thank you all. Please do subscribe for the channel and get updates on more on domain analytics, other domain analytics, so that you can keep update yourself and upskilling your skill. Thank you all.